Okay.
Welcome to another edition of webinar series on MBA Rendezvous, which we conduct with academic leaders and thought leaders of the industry. And today we have with us Koray, who is the CEO of Holistic Digital and one of the thought leaders of Semantic SEO. Welcome to the show, Koray.
Thanks so much for having me here. It's a great pleasure and a great honor too. I can tell that I have attended many events for SEO, but I guess this is the first time that I am attending an event for mainly the academicians and scientists. So it's even more meaningful for me.
Wonderful, wonderful. So Koray, how we would like to start is that we will like to start at the very top so that everybody is at the same context, and then we will try to go deeper down and unmingle the stuff.
Okay, we can do it. We can do it in that way too. Maybe we can start from definitions of the semantics and semantic SEO, semantic web and semantic search engines. Then we can also try to understand why the search engines have to be semantic and more, and why do they continue to improve their language models? Why do they spend more than $10 billion every year for just improving these language models? And then maybe we can even expand it beyond SEO, because when it comes to the dialogue systems based on NLP, or when it comes to the understanding the human language, it's not just for search, actually, it is also for personal life assistant robotics. For example, Google also is in that industry, and they are using their latest language algorithms for their latest robot, which is Butler. So we can try to understand all these things in a composite way. We have like 57 minutes, so I believe it will be good enough.
Wonderful, wonderful. Right, Koray. So let's get started. So can you first, at a brief, help us understand what exactly is semantic SEO, and then dwelling down under it, what is semantic content network? How do we create that?
Of course, I will be happy to do that. So first of all, let's start from the semantic search engine optimization. So basically, around 99, I believe, in the last century, the Sergey Brin actually has filed a patent, and it was actually about finding patterns on the web for extracting information. He even called it deep re, because he was using actually regex, and he was trying to understand the deep patterns on the web, because he assumed that instead of matching the strings, or instead of just checking the link popularity in a link graph, he assumed that he can actually use the actual information, actual entities and actual existing things in the real world. And he actually crawled and scraped entire Amazon from that year. And he actually found more than 500,000 books, which was amazing for that time. And then he realized that recognizing an entity as is so hard, because he actually encountered a couple of common problems. First of all, some of the books, let's say 7% of the books, they were fake. And even if the books are real, the authors were fake. Or even if the authors are also right, the author names were wrong. And sometimes a website or a web page or a seller was telling that the book is about X, but another one was saying book is actually about Y. So when we look at these things from the Sergey Brin's point of view, like around 23 years ago, he was confused, because he assumed that this is, first of all, maybe it might be better, but it is too costly to understand the entities, connect them to each other, extracting the information, and also checking the accuracy. Then they actually started to focus on relevance rather than understanding the document. So when it comes to the semantic search engines, the SEOs, they usually make a distinction mistake. First of all, understanding relevance of a document to a query is not the same thing with understanding the document. You might understand the topic, context, and also even the purpose of the document, but it doesn't mean that you are understanding every sentence there or every meaning there. So that's why since 1999, the search engine Google, actually, they had to focus on relevance understanding, context understanding, topicality understanding. Then we had Anna Patterson, and she actually manages the Google Ventures at the moment, another data science and AI sub company. And Anna Patterson actually told that certain phrases appear together with certain phrases and in a certain way with a certain word proximity. Then they have started to create some phrase lists, and then they have started to measure actually which phrases have more weight for certain topics. Then they started to divide entire web into the different sub-contexts. Imagine that you are using a phrase with another one, and they assume that, okay, this document has to go this index for these queries. But if you add one more, it will start to go another one. If you use all of them, it means that actually you will start to dilute the context. So these things actually were the early days of the semantic search engines. And the semantic SEO is actually understanding why the search engines have to be semantic and optimizing the websites or the sources according to these needs. And today, they are very much more beyond these type of things. They just don't understand the relevance. They also understand every passage. So that's why from time to time, for example, the passage indexing, instead of ranking a document according to its overall relevance and overall quality, they just index a single passage and they just rank the passage. So it is actually a revolutionary thing because it means that they are changing the index construction. In the old index construction, they were indexing documents for queries, but now they are indexing passages for questions. So it is a new era for search engines too. And if you think in this way, semantic SEO is actually optimizing a website based on meanings, concepts, and also semantic similarity, semantic relevance, or even semantic distance. And when you understand and collect these things with information extraction, you will be able to actually create best possible query responsiveness. To be able to explain the last two concepts, one of them is query responsiveness, the other one is information extraction. I will need to explain their point of view. So let's say we have a document. In the old times, we were able to understand the relevance. So we can tell that, yes, this document is relevant to this query. So it is actually understanding the relevance. But we don't know whether this document actually has the right information, necessary information, or whether they are able to respond to the search need behind the search query or not. We just tell that it is actually relevant. So in the old days, search engines actually were taking the most relevant documents, then they were filtering them out according to the page rank. If the page rank is high, it means that actually it is quality. And since it is relevant, we can serve it. But today it is beyond that. We need to extract the information. So information extraction is different than information retrieval. Information retrieval is to understand overall relevance. Information extraction is actually for extracting or pulling out that specific information from the document and giving it to the user directly. So it is very much better for users too. And while doing that, the search engines realize that certain sources, they have more information to be extracted and they have higher accuracy. Then they have started to use this information accuracy and richness and uniqueness for balancing the page rank, because they have realized that some sources, they are relevant, they don't have page rank, but still they have high level of information. So it means that we can actually balance the page rank by benefiting the information-rich websites even more. And semantic SEO actually focuses on this information accuracy or relatedness even more. And in this case, we need to talk about semantic content networks, because it actually comes from the semantic networks in knowledge representation. And I am sure that most of the academicians in this channel, they have used these methods in their lives while thinking even. Knowledge representation means that we actually store the knowledge in different represented forms. These forms might be networks, or they might be frames, or we have some other logical representation methodologies for knowledge itself. But the best one that can be used by the search engines for cheaper algorithms is actually semantic network. So if I create a sentence like, let's say, the Hamlet died because of a poisoned sword swing or something like that. The search engine will be able to understand which entity is this in an easy way, but beyond that, they will take the sentence, they will parse it, they will take the entity to here, and they will give it a death cause, and then they will actually put the death tool or something like that, and they will put also the poison there. So there are missing parts there. For example, which poison, who used the sword, and what was the date and the place. And also what was the reason for that fight, because sword is a tool for fighting. So when you use these semantic networks, the search engine is able to assign different semantic role labels to the every existing thing in the sentences, and they create a different graph or a different network based on that. And they actually call it data to text or text to data. They take a regular text and then they start to actually put it in the form of a data frame. And they do it from multiple other sources. Then they realize that some of the sources, the reliable ones, they usually give certain things with certain values and certain forms. Then they start to actually improve their language algorithms and also their knowledge graph and knowledge base according to that. And the Semantic Content Network is actually creating a semantic network in the form of content. So we try to understand how Google thinks and what Google thinks and why it thinks in that way. Then we try to create the best possible information graph in our network by dividing network into the different web pages. And also we try to organize every heading vector, context flow, and also content format. We try to even optimize every sentence structure. And even we choose the most possible or probable predicates and predicate lemmatization so that the search engine can increase the confidence score even further. And once we create our semantic content network, search engine actually can come, scan the text and also visuals too. Then they will start to create a semantic network from the information that are stored in our content. Once this semantic network has been created, they will start to compare it to the other sources. Then they will start to compare it to their own knowledge base. If there is added value, unique information, and if the content is in a better shape to be processed and evaluated, it means that actually you are giving higher accuracy and more information and in a more cheaper way. So basically, this is what the semantic content networks.
Wonderful, wonderful. That was interesting, Koray. I have a follow-up question on the content.
Of course.
So when we are speaking about semantic content network, does Google create this network per document? Is it per page of the website that a network is getting created and all these networks are then interconnected by the interlinks? That is how Google works?
Yes, because in 2019, they have actually officially announced an update, and they called this update as neural nets, in other words, neural networks. So when we use the term neural network, it is actually a concept for deep learning. And another problem there is Google has a tendency to name any kinds of algorithm with the word deep. For example, the BERT algorithm, they were calling it deep ranking rather than just BERT, for example. So even that actually shows how the Google engineers think. They want to use neural nets or neural networks all the time because it is an imitation of our own neurons. And it is highly appropriate because a semantic search engine has to use neural networks too, because there is always a network. That's why the alternate names or alternative names for semantic search engines are association engines, or sometimes it is understanding search engine, sometimes it is called contextual search engine. But when it comes to creating these networks, the Google has to create upper hierarchies and lower hierarchies in this semantic network. And they can't only store a single information there, because every source gives a different object, a different fact, and a different URL. And in one of the patents from Google, it was actually identifying facts across different web sources. And there is one more, for example, it is called corroboration of web answers. And all these researches, corroboration of web answers, it is actually a research, not a patent, but the other one, the identifying the facts across the web sources, it is the patent. And in all of these things, actually, they try to create semantic networks. They call it actually knowledge graph or subparts of the knowledge graph. And once they create these semantic networks, they actually start to create different sub-levels and upper levels. And as I say, in 2019, they have announced the neural nets update. They also called it subtopic update, because every topic is also a subtopic for another one, and they are all connected to each other with different hierarchies. And when you think in that way, Semantic Content Network is actually trying to consolidate all of the contextual relevance for a single topic, and with all the facts just for that. If you start to touch or write or talk about another topic or upper hierarchy topic, you will also need to complete it. So that's why it is a little important to create proper borders according to that. And it is one of the problems for semantic SEO too, because in your perception, a topic shape might be like this, but in Google's perception, it might be something else. You might think that actually this topic is more important than this one. It should be placed here, but Google might take that topic and put it into the somewhere else. And in broad core algorithm updates, actually, they just adjust the relevance distance. You might assume that a topic is more relevant to this one for now. But after the next core algorithm update, they can take this topic and put it there. So it means that actually now the queries here, they are not that relevant to your document anymore. And you will start to see new sources and new documents actually are ranking there. And that's why while creating a semantic content network, you will need to guess these type of changes. And you will always need to create enough level of relevance for every understanding. That's why usually in my semantic content network designs, I don't leave any kinds of gap. I try to cover everything with a proper order, so that even if Google changes their opinion, still I will stay relevant and also accurate and responsive.
Wonderful. And we are so looking forward to your course on semantic SEO, so that we can go deeper down to understand how to create that.
Thank you. If I wouldn't have these health issues, actually, I was thinking to launch it, but it's ready and it will come. There are many scientific researches. I even have written a book, by the way. I didn't publish it yet. It actually focuses on question generation from keywords. You will find many things there too, from the search engine's point of view, at least.
Wonderful, wonderful. Koray, I'll take a step back and then I'll go deeper into the semantic content network again, because there are a lot of thoughts which you have shared and which are very interesting to discuss. So let me go a little higher and speak about the topical map first, right?
Of course.
Right. And then we'll connect the topical map with the semantic content network. And then we'll try to go deeper into the semantic content network.
Okay. So when we look at the topical map, as actually it's a new concept, to be honest. Probably I have used it. The concept of topical authority, it started to exist around 2011. It's actually before me. But when it comes to topical map, I am the inventor for that. But it actually comes from the concept of topical graph or concept graph. Because as I say, when you start to design your semantic networks, you will realize that there is a map there, a map that you will need to process. Then you will also realize that some of the nodes in the semantic network, they are centroid, they are at the center. So it means that you will need to take this thing into your document title, and it will be the macro context. Then you will need to take the things around it, and then you will need to create a proper contextual flow for explaining all these things. And when you realize these centroids, you start to actually create a kind of order to what to process and to what should be connected to exactly what. And these things actually are topical graphs or concept maps. Concept map is also a term from knowledge representation, because there are many concept maps, by the way, especially for medicine, and they're also public. And it will be actually a good education platform too, Because when you look at the concept maps for medicine, you will realize that there are different concept maps for the same disease group or same concepts. And then you will actually understand that, okay, one of them actually puts this disease under here and they connect it to the here. But in this concept map, its place actually changes. And topical map is actually choosing the centroids from these semantic networks, putting them into a kinds of graph. And also when you put them into a graph, you will understand your internal link design. Basically, what will be connected to what with what link text. And once you order these things, you will actually have basically a topical map. And when you create a topical map, it is like the Google's own subtopic update, because a topical map might be a subtopical map for another one. For example, in one of my SEO case studies, probably I have created more than 150 different topical maps for different topical maps for every different context or main entity or also macro context. Once I create these topical maps, I start to connect them. I start to give them also a hierarchy. And when you unite all these things, you will actually have an information tree, an information graph. And if your information tree is appropriate to Google's own perception, it means that actually they will start to increase their confidence score for you and also for the information that they have, because according to the Google researchers, they might change their opinion. You can ask the mile age of Honda Civic to a search engine might actually give contradicting information, because information on the web is contradicting. And then Google might actually have a higher confidence for mileage of Honda Civic. And then they can actually start to filter out the wrong answer, giving wrong answer sources that can also reflect this inaccuracy situation to the other neighborhood content as well. And basically, actually, that's why they have created their own product graph, and they are competing against Amazon for that. They want to understand products very much better. It is also a good example why the semantic search engines matter, because if you want to compete against Amazon, you have to understand every product rather than just matching the queries to the documents. So it means that you will need to understand every product dimension, like type of the product or battery of the product or even maintenance, material size or other things there. So when you create these topical maps, then there are a couple of more things there too. For example, defining the topical borders, where a topic ends and where the other one actually starts. Then you will actually need to also understand the query templates, because according to the query patterns, you will have to reorganize your also the title of the documents. If you change the title of the documents, it means that your context flow inside of the document, it will need to change. If some of the entities or some of the concepts, if they're not appropriate for that document macro context, it means that you will need to expand your topical map even further. So there are these type of things there. It is a little hard to implement, but when you are able to create these things with discipline, you will get the results.
Wonderful. We have been trying internally to do it. We passed, we failed, we are trying to pass again.
Yeah, it's a continuous process actually. In one of my videos, I have also explained that. I have written a case study. Then actually I started to lose some of the traffic. Then after 6 months, it came back like 4 times more. So from search engines point of view, it takes really good amount of time to understand these documents, process the text. It's not that easy to do because when you look at these things from the search engine's point of view, processing a text, a corpora or a corpus, a group of corpora, in other words, it will take too much time. It will be really costlier, and most of the time it won't worth it, because I can try to recognize entities in every document. I can try to use every kinds of quality algorithm for understanding the internal links of a website. Then another algorithm might come and tell that you are just wasting your time because this website doesn't worth it. And for example, Google, they have 3 different tiers in their indexation index. And they have explained these things in their Search of the Record podcast. They told that there are 3 different tiers in our index, and the tier 1 has the most quality websites for serving them faster. And even if we have an energy consumption problem, we always keep the tier 1 alive so that actually people can reach out these most important sources, most important websites. But when it comes to tier 2 and tier 3, they can die from time to time, and we don't care about them that much. So even if Google doesn't put every website into the same computer, same data center, it means that they also don't use the same algorithms all the time for understanding them. Because to make Google use these expensive algorithms in your website, you have to give high level of quality signals so that they can actually understand the information graph in your content. And that's why at the beginning, usually I tell my team members and also clients that they should focus on impression increase rather than actually click increase. If you exceed impression thresholds for certain queries, Google will actually come back and they will start to process the text to see whether actually you have more than just the relevance, because impression increase, it comes from relevance. But if you want to increase your clicks, you will need to show that you have the information, and not just information, but also the function. You will need to be responsive for information need or action need on the web during the search, and it will continue like that.
Wonderful. Just to revalidate my thoughts, Koray. So, are the semantic content networks the nodes of a topical map? Is it correct?
Yes, actually, when you create, let me explain the difference between them. As I say, the topical map, it has only the centroids in a network. Let's say you want to write all different, let's say just the cat foods. And you will realize that some of them are more important and they are the centroids. You will need to put these things into your topical map. And the other ones, the ones that are around the centroids, they will actually go inside of that document, but they won't appear at the macro context of this document. So from Google's point of view, a document has 3 sections: ads, main content, and supplementary content. The main content actually has the macro context. According to David C. Tyler from Google, they actually realize that every document has a macro context, a macro layout, certain types of web page components, and a single main topic. But at the bottom or around the middle, they realize that there are also some subtopics or side contexts. And they use these side contexts to understand the document connections across different web pages. And when you have your topical map, you actually have the main entity for that document and you have the macro context for that document. But when it comes to process these attributes and some of these subcontexts, you will need other entities around that centroid. Once you have these other ones, the outer section of that centroid, you will need to put these things into that document. If you unite these documents, you will have a semantic content network. But if you just look at the topical map, you will just find what you will process for what context. The semantic content network, it actually includes everything there as processed and also connected to each other.
That makes a lot of sense, Koray. Wonderful. Okay. So let's go down to the document level now, right? You speak about quality thresholds of the score, quality threshold score, right? So that is very interesting to understand. And when you speak about creating unique engrams and context vectors, can you help us understand more at the document level now? What exactly is required to optimize a particular document at the
I will try to give a couple of terms and concepts. I believe they will make thinking easier. One of them is uncertain inference. The concept of uncertain inference, it actually comes from Glasgow University and Information Retrieval Club from there. The inventor of the concept is C.J. Bergson, a Danish, I can tell. I'm not good at pronunciation of the Danish last names, to be honest, or city names or nothing in Scandinavia. So basically the concept uncertain inference, it tells that a search engine, even if the search engine has all the intelligence, all the energy, all the money on the world, still they can't be 100% sure for the meaning of the query. So uncertain inference principle accepts that they always have to focus on probable probabilities. And once someone actually searches any kinds of query, the thing that the search engine will do is rewriting the query. They will have to rewrite the query in different forms. And these things might be implicit questions. These things might be entity seeking queries, answer seeking queries, or these things might be emergency crisis queries from the Google's own perception. That's why in my slide share, I have as a presentation, it is called Semantic Search Engines and Query Processing. Because if a search engine is able to process a query with all the probable probabilities, then they will start to understand what are the possible contexts around that query. Once they take these contextual zones or contextual domains around the query, they will start to distribute all the query candidates or query refinements around that the query that has been searched. Once they distribute these query candidates or variations to the different contextual domains around it, then they will start to understand some of the contextual domains are more important than other ones. And when we say a context vector, it means that actually we have two different terms side by side, and we are able to vectorize it. In other words, we are able to use word embeddings to create a vector. Maybe I should explain it a little further. As you all know, vector is basically a line in a coordinated space. And in a coordinated space, when you have a vector, it means that you have a representation of something else. Yeah. And every word can be vectorized. You can actually use the words, let's say A and B can be like a vector like this. A and C can be a vector like this. And difference between these two vectors, it represents the semantic distance between A and B and A and C. If the distance is closer, it means that actually they are in the same topic. If the distance is a little higher, it means that they are related but different topics. If it is too distinctive, it means that there are different vectors between them. So once you understand these context vectors, you realize that certain context vectors belong to certain contextual domains. And all these contextual domains, they have been created by uncertain inference. And once you see these, all the probable probabilities, you will start to create a proper contextual coverage in your document. Then you will also realize some of them are more probable plus more important than others. Then you will need to actually process all these things side by side or within a hierarchy. And then you will also need to create different internal link designs to the different sections of the network. For example, in one of my case studies, I have published it with autoritas.com, another tool for SEO, and it was for an energy consumption brand. I can tell that it was a really good project. And this energy consumption related brand, basically they were an aggregator for changing the electricity distributor. And for that project, I actually processed every context of electricity, because when you talked about the electricity and the prices, now it is a consumer good. If I just talk about what electricity, it is about science and it is entirely different. If I start to talk about production of the electricity, it is about technique, which is another thing. So imagine that you are just searching for the electricity, and Google actually called it dynamic serving of the content. If maybe you can find it if you search things from the United States. When you search for something, Google starts to give some sidebar at the left side of the SERP, and there are different contexts there. Sometimes they talk about formula, sometimes it's about books, sometimes it's about even recipes or something else there, or just images. All these subsections, they actually represent different sub-contexts and contextual domains about that query. And that query, the search engine is not sure about what you mean. That's why they use uncertain inference. Then they start to create these contextual domains. And in that project, I processed everything there, basically, by creating a topical map. Since I created a topical map and processed everything, for every possible contextual domain, my website always stayed relevant. And search engines, they are not that volunteered to find every website on the web and give them a chance on the SERP. But if you make search engine realize that for every possible contextual domain, for every possible uncertain inference, always my source is relevant, always my source has accuracy, and in every possible scenario, I have the right answer. So it means that ranking you is cheaper and easier. Rather than just searching billions of documents, I can just go to you and I can check your document. And if it is similar to the previous ones, I can just rank it in a quick way. And this is how actually machine learning works. And it is also another topic because, as you know, Amit Singhal, he was a Google fellow and Google engineer, highly respected engineer. He had to leave the Google, but he did good things there. And he was actually against using machine learning for search systems. Because when you use machine learning for search systems, there will always be outliers and you won't know why. So it means that if you are losing traffic on Google, sometimes it might be because of an algorithmic error. Maybe you didn't do anything wrong and Google machine learning systems couldn't understand what's going on there. That's why sometimes, even if you do not change nothing in your website, and even if your competitors don't change something in their websites, you can lose a core algorithm update and then you actually win it back for the next one. So you changed nothing, but from Google's point of view, they have improved their algorithm or the contrary. And when you use machine learning for the search systems, you will have to label the websites, the passages, or anything basically there. And when you start to label these things, you will need to create other different labels. That's why actually once Fabrice Channel from Microsoft Bing, which is another semantic search engine, he told that to weight different factors, which are different labels, they just actually use different algorithms and usually they choose the cheaper one, the most convenient one for them. If the results are good enough, they go with it. And when you think like that, to be able to create the best possible document, sometimes you even need to calculate the possible mistakes from the search engine point of view. That's why sometimes you need to go beyond for your source, even if you are not that relevant to that specific query or to that specific concept, still you will need to include it for the sake of uncertain inference. And if you're able to do it in a proper way, you will always stay relevant, responsive, and the search engine will have to rank you once they realize your source.
So does that also mean, Koray, that when we are speaking about uncertain inference, the cost to produce the content goes higher because you are covering a lot more things?
Yes, actually it is. It depends on your approach there. For example, in my situation, usually it goes lower because I don't let authors to write fluff. As an example, I don't let my authors to use the word also, because in search engine optimization, every word, if it is possible, it should be contextual. If you delete a word and if it doesn't change the meaning of the sentence, if the grammar is not broken, it means that that word is not necessary in that document, just delete it. Because search engines, in their language algorithms, they use attention spans. That's why the motto of BERT is attention is all you need. You can't actually process entire corpus at once. You can't process 2 billion words at once, but you can create a window, an attention window, and this window can actually wander 2 billion words for you. They can take every word seconds for you while labeling every word with word sense disambiguation and role of the word. Then they can take all these data, put them into a data frame. Then you can actually start to create your own language model by checking which word appear after which word with what suffix, with what role. Then you will get all these probable probabilities. That's why actual language models, they don't understand the language, they just imitate it. You write something and they take the best possible candidates and then they actually continue to use these word sequences. They create different possible candidates. They choose the most probable one. And that's why we also have bias in language models. When you say doctor, the language model assumes that it is he. When you say maid, language models assumes that it is she. And that's why in Google Translate, for example, they try to fix these type of errors by manipulating the data. And when it comes to the semantic search engine optimization, the cost of the article production, it doesn't have to go higher, because when I create a document template, because certain types of entities, they can use same type of document template. They have same attributes and they have same questions that are asked. It means that the answers are highly relevant. So I actually write a single document, maybe for even 40 different entities from the same type. Then I put their attributes into the document. I create the sentence structures. The next step is just replacing the information section. For example, capital city of Germany is Berlin. I can use the same sentence structure also for France. The only thing that we will need to change is just the names of the entities. That's it. You don't need to write things from zero. Just replace them and move on. And when I do these things, the authors, they realize that they are not writing the article. They just replace the information for that specific entity this time. And they always use the same sentences, same sentence structures, or same question formats. Of course, this is a bulk production methodology. So it means that sometimes you will need to change the attribute orders, because in my understanding, I use 3 criteria for attributes. One is attribute prominence, the other one is attribute relevance, the other one is attribute popularity. Attribute popularity, it comes from the search demand. Attribute relevance, it comes from relevance of that attribute to the topic that I am processing. The prominence of the attribute, it comes from the definition of the entity. For example, you can't imagine a country without a population. Every country has the population. If there is no population, there is no country. So even if the word population, or even if the attribute population, even if it is not searched that much, even if it is not that relevant to your topic, even if it is not popular, still I will need to include it in that document, because it is highly root attribute. Without that root attribute, I can't define it. Some of these things are called subjective attributes. Some of these things are called actually, for example, in one of the patterns, question generation from knowledge graph. They take the attributes, then they take the question templates, then they actually variate these things so that they can generate the questions, as in people also ask questions, for example. And once they create these questions, it is highly easier to find the information. And it is the main thing there. That's why in my book, I have focused on question generation, because in information retrieval, you are matching document to query, but in information extraction, you are matching question to answer. So it means that you will need to generate questions so that you can find the answers. And to be able to generate the questions, you need queries and uncertain inference. And once you have the uncertain inference to process the query so that you can generate the questions, you will start to actually realize that certain templates are better, certain predicates are better, certain sentence structures are better. Then you will have a standardization for writing. And then the authors will start to write faster, better, and also it will be cheaper.
That is very interesting, Koray, because we have been internally trying to optimize our document structure with help of Google's NLP demo tools.
It can be used too, but the main thing is that if you leave authors alone, all of them will write different things eventually. Yeah. They will use different sentence structures, they will use different stop words or word sequences there. But usually in my situation, especially in the projects that I manage in a fast way, in a successful way, I create certain types of sentence structures. Even sometimes I write it with variables. I don't tell Germany or I don't tell Berlin, but I tell X, Y, Z, C between different sentences. They just replace these things by making a research. If sometimes we have a better, more important attribute or site context, sometimes we fix these things later. Sometimes I give authority to authors to change some of these sentences by adding extra information for that specific one. But it requires too much working, and I can tell that every client is not appropriate for these methodologies. because sometimes they want to have the control, they want to understand why that sentence structures, etc. And then you will find yourself while teaching these things rather than doing these things. So that's why if you find the right mentality from the client for implementing these things, if the authors are diligent people, you will find yourself while spending less money for more articles.
Great. Koray, you have also been mentioning about creating unique engrams and engram clusters in your article. And I also understand that you are against using the word keywords, but I wanted to maybe understand from you, when we speak about engrams, are they actually different? What is the difference between an engram and a keyword there? And how do we create engram clusters, and what is the difference between keyword cluster there?
Okay, so from Google's point of view, and by saying Google here, I actually mean Stephen D. Baker and Nitin Gupta, and they are really important. They were really important Google engineers, and they are the brains behind the feature snippets, and they call them web answers. And there, actually, they defined that especially specific engrams, for example, the foregrounds, they're the best possible tool for them to find the best possible answer for certain questions. And they call these engrams or different types of engrams answer terms. So according to them, for certain topics and certain question templates, they have certain answer terms or word sequences, and they use these answer terms or word sequences in the forms of foregrounds so that they can understand which source actually has the added value and a proper answer there. And I use the word query instead of keyword because the word keyword actually it comes from journalism rather than search engine optimization. And it is for actual offline marketing, but not just the marketing. It is even for politicians and politics or talks. But when it comes to the query, it is actually, by saying the query, we actually mean search query that has put into a web search engine. So when you look at a search query for a web search engine, we can't use the term keyword there because keywords are actually for making a message explicit, for making a point explicit. But when it comes to the search query, it is for relevance. So their origins and purposes are actually entirely different, but usually the SEO world, they don't read that much. They just follow what others do. So if someone tells keyword, they also tell the keyword, but their meanings and contexts are different. And when it comes to the understanding these search queries in a way that search engine actually does, you will need to understand how the Google engineers think, and then you will need to read their thoughts. For example, there are two really important philosophers in Google, in my opinion. One of them is Dr. Nayak, the other one is Dr. Messler, and they both now actually work on changing the understanding the web. For example, in one of their names for their research is called rethinking of web and finding knowledge domain experts. So now they try to understand who is the real expert because it gets harder. And when it comes to actually Dr. Messler, for example, his latest research is actually about multi-dense retrieval. So let me explain it because it is touching these engrams or unique engrams. So when we look at the dense retrieval, it is called dense because we are taking entire corpus or maybe long sentences, then we use a single word for defining everything there. We choose the most representative and important word that appears in that area, and this is called dense retrieval. So they take the query and they dense it too. So we have a representative word for the query, and we have a representative word for that passage. If these words are not matching, it means that they are not matching too. But Dr. Messler says that it works for until certain levels. But when we check that, actually, if we choose the wrong dense, it means that the retrieval also will be wrong. Again, we will catch some context, but we won't be able to respond to the need behind the query. We will just give an overall relevant document to match these things. Maybe you will actually ask how to park your car, and we will give you an answer for actually parking maybe something else, and a toy car, for example. If the word toy is not chosen in the dense for dense retrieval, we will give you the wrong answer because we will assume that they are highly similar to each other. So that's why Dr. Massler thinks that multi-dense retrieval is better. They tell that for queries and also for documents, we should choose multiple denses, multiple representative words. If you choose multiple words, it means that actually the accuracy will increase. But also what else will increase? The cost. So that's why it's actually a research paper right now rather than a patent or update. But still, they work on these things. And let's come to the unique engrams and their value right now. Because on the web, there are, I don't remember the exact count, but I guess it was higher than 180 trillions of web documents. And 70% of the web, it doesn't have any kinds of traffic. And the rest, when you look at that 30%, 98% of that traffic comes from crawlers, bots, or harmful programs. So only 2% of the traffic on the web is coming from users. And it is only for really, really small portion of the web. And 96% of the traffic on the web, it actually goes only to do like 3 or 4% of the web. So if you think it like that, nearly 99% of the web is not necessary for the search engine, but still they have to crawl all of these things because they are linking each other, and you will need to understand the relevant importance of these documents in a complete link graph. So that's why when you think like that, they are increasing their cost all the time. For example, we have one latest research from Google. It is called Adaptive Confident Language Model. And they tell that, and you can even unite these things with Dr. Massler multi-dense retrieval research. Let me explain. In multi-dense retrieval, we try to create multiple representative words so that we can increase the accuracy for matching these things. And in Adaptive Confident Language Model, the research says that to understand a document, we don't have to use entire language model. We can just choose an adaptive section, a section that we can adapt by actually using it. And they call it confident because they know that at least maybe 50 times they will use the wrong portion of the language model. For example, like around 10 minutes ago, I have talked about word sequences, attention span, and creating a data frame with word sequences. So imagine that to understand your website, Google uses only the top section of the data frame. That's why it is called adaptive, and they will check the confidence score. If the confidence score is not exceeding the threshold, they will choose a different portion and they will try it. And then eventually they will understand which portion of the language model is better for which portion of the web. If they're able to do that, they will decrease the cost. Then they can actually use multi-dense retrieval. So their research papers are always like this, increasing quality while decreasing the cost or protecting the quality. And when we look at these unique engrams, it shows Google that, okay, I am crawling this topic for maybe last 20 years, and I have actually seen this phrase taxonomy or phrase combination first time. It's not similar to the others. So I can't shadow this source. I can't delay this source because it is unique. It adds real value and it gives more information than others in a compressed way. And there are more entities, more declarations, and more states. Every context is actually flowing according to my SERP and according to my understanding. And then actually they will start to understand that it works for crawling. If it works for crawling, it means that actually they will continue to crawl more. If you exceed the quality threshold, they will go deep for your website and they will use all the algorithms. Then actually you will see the re-ranking. I have also explained the ranking algorithms, re-ranking and initial ranking. And once you exceed the threshold, whenever you exceed it, you will see another re-ranking, and it will always continue like that. And in my latest SEO case study too, I have actually uploaded new screenshots and new explanations. They will be uploaded too because it continues to raise. It actually doubled again. So it always continues like that as long as you actually exceed the threshold. Engrams there, or engram clusters, it is important for taking the attention of the search engine, because using a single unique phrase in your document is not good enough for the search engine. They can't pay attention to that. But if most of your engrams are unique, imagine that I am tokenizing your document, aggregating all the engrams, and I see that the most used ones, they are unique. So it is relevant to the topic, it is more accurate, but also it's not similar to others. So it means that they can place you directly into the SERP. It is called information foraging. Information foraging is the process of constructing a SERP that actually can cover everything. And if you are highly similar to the websites that are already ranking, it means that you are not necessary on the SERP because we already have you there with a different name. From search engine's point of view, it doesn't matter whether you rank or whether someone else ranks. They just want to satisfy the user. But if you are not similar to the others, if you are unique, it means that actually if they put you into the SERP, they are increasing the click satisfaction chance. You are not similar to others, it means that actually you deserve to rank there. And it's the point there. That's why I'm trying to actually create unique engrams and unique engram clusters.
Wonderful, wonderful. So I'll come down to my last question, Koray, because I also want to have a small informal chat with the team before we let you go today. So I'll come down to my last question. So what is the mantra to get onto this featured snippet, the zero position that you talk about?
Okay, in the course, actually, it will be really fun because there are many different sections for explaining that too. But the biggest thing that I can tell there are certain word sequences in every feature snippet or every feature snippet group. So we might assume that there are table feature snippets, there are list feature snippets, and there are paragraph feature snippets. But these are just the fundamental ones. If you go beyond that, you will realize that there are certain needs. For example, if the query has a superlative word, if you perform a part of speech tag there, you will realize that queries have certain types of words like superlatives. If you have a superlative in your query, it means that your answer has to be comparative. You need to have multiple things from that type and you will need to compare them to each other. If you have too many things from that type, you will need to choose the main ones. And it's not good enough to choose the main ones. You will also need to tell the main ones or the most important ones. For example, when it comes to asking difference of two different things, you have to tell the main difference in your answer. If you don't tell the main difference for both of these things, the search engine might not choose you because there are many other differences there, but which one of them is the main? And it is highly relevant actually to the corroboration of web answers because later search engines started to show multiple sources, multiple websites with multiple passages for the same question, because they also don't know which one is more accurate and which one is actually better. So that's why they actually choose 5 or 6 different answers and they put them in a list. And if you look at these answers, they usually touch highly similar or slightly different things. If you ask for harms of X, let's say it is a health topic, if you see the cardiovascular in the first answer, the next one might talk about immune system, or that one actually might also talk about diabetes. But if all of them actually talk about cardiovascular, they can be competitor to each other rather than alternates. So in this case, when you look at the existing feature snippet, you might actually need to alternate that answer rather than repeating the same one. But if you're able to understand directly the sentence structures for certain questions by performing part of speech tag, you will be able to take their feature snippets. And usually this happens as bulk, not one by one. And one more suggestion from me is you should understand that feature snippets are not permanent. In other words, at least always, at least for 10% of the time, the owner of the feature snippet changes. If you find which one is the alternate, you can actually create a way much better sample for the search engine. And then if you are able to prove your overall authority with the accuracy, you will start to get feature snippets as bulk, as suddenly after certain updates.
Wonderful, Koray. Thank you so much for this insightful session today. I am sure all the academic community in India would really be excited to listen to your thoughts on semantic SEO. And
thank you
once again for your time.
Thank you. It was a pleasure for me to hear. I try to keep things simple, but sometimes we had to talk about complicated things like dense retrieval or uncertain inference and other things. But I am sure that our audience, since they're academicians, they will understand most of the things that we talk. And thank you for having me here.